Greetings, AI students. In the previous video, we saw our very simple one neuron neural network, which we want to have it compute the logical AND function using ones and zeros for true and false for the two inputs. And we got as far as noticing that our neural network, which started with random values for its weights, failed on this line of the truth table. The true and false. X1 is true, X2 is false, and we got a 1 out, a true out, but true and false is 0, is false. So the error there is -1. -1 is how to get from the correct from the calculated output to the correct output. So from the calculated output, we need to change our output by -1 to get what we wanted. So, all right, as I explained, the error points back to where we want to be from the wrong answer we got. So the main idea over here is going to be to, we present the network with test data, which we started doing. If the output is correct, there's nothing to learn. But if the output is wrong, we're going to nudge the weights in a direction to help the network emit the correct value. And why do we nudge the weights? We nudge the weights because if we slam the weight all the way over to 0 or 1, we could end up clobbering some other case. Remember, what we have here is we have the error from one case. Right now we have the error from this case here. True and false. All right, and if we were to just correct the weights right now so that we're guaranteed to get the answer we want, we might clobber the results for some of the other cases. So what we're going to do is we're going to nudge it, and so we're going to take 0.1 times the error. The error over now is going to be either 0 or 1 anyway, so the nudge value is going to be plus or minus 0.1. So this nudge value is then going to be applied where? Well, again, looking at this case here, we notice that, okay, the X1 input is the sole contributor to that sum. X2 didn't contribute anything to this sum. X2 was 0. This sum was independent of X2. So since the sum was wrong and the whole sum came from X1, what we need to do is we need to adjust weight 1 and ignore weight 2. So we're going to adjust weight 1 by 1/10 of the amount that would get us back to correctitude. Okay? So we'll adjust weight 1, and weight 2 we don't change because weight 2 didn't even matter in this case. All right. So if we do that, if we adjust weight 1 by -0.1 and weight 2 by 0, this is our new weights. So going forward, you remember each line of here is running one test case through one training and test case through the neural network. Going forward, we're now going to be operating with weights like this. All right? So, what happens? The next case was false and true, and we will multiply 0 and multiply that by 1. We get a sum of -0.1. -0.1 is less than the threshold, so the output is false. False is what we want. The error is 0. No change. Next line of the truth table. Next line of the truth table is true and true. So 1 times that plus 1 times that gives us a sum of 0.1. 0.1, going back here, 0.1 is less than our threshold. So the output's going to be 0. So true and true, 1 and 1, is going to produce a 0, which is false. Here's the correct output. Here's the error. Okay? So the error is starting from 0. We need to increase it by 1 to get the correct output. That's the error. All right? So what are our adjustments? 0.1 and plus 0.1. So we're now done with what's known as the first epoch. One epoch is kind of one run through the training data. And now we're going to run through the training data again. But notice that we had these two adjustments to the weights. So this is our new weights going forward because we added 0.1 to both of them. Now, two things I want you to notice. One of them is that a negative weight for W2 was probably not correct. That there's no situation where making that sum lower, putting a true in, making the sum lower is going to help an AND function. You know, more trues like contribute to a 1 input contributing towards a 1 output. So intuitively, the negative weight was going to be wrong, and that's now 0. Intuitively, 0 is going to be wrong also because that means that whatever is in x2 here is going to be ignored. It's always going to be multiplied by 0. We also note that weight 1 is now back to 0.3, which is where we started. So it kind of looks like we haven't improved things. It turns out we have improved things. But we've improved things by making this one no longer negative. But let's keep going. So anyway, our first line of the truth table was 0 and 0. That gives a sum of 0. That's false and false. Produces a false. Everything is good. No change. Okay. 1 and 0. That's going to be what? So there's no change in the weights. If there's no change in the weights, we'll just keep the same weights. Okay, and I didn't mean to color those, so let's one color automatic. It's not the font I want to change, it's the background. Thank you. Okay, so this becomes 0.3 plus 0. The output gives us a 1. True and false is false. Our error is minus 1. So, minus 0.1, because x1 is the one that is a 1 there, so that's minus 0.1. Okay, and x2 was 0. Since x2 did not contribute to this erroneous result, we will not change its weight. So that's our error. That's our corrections. Let's just color those briefly so we can see them. Now we apply our corrections for the next round. This becomes 0.2 again. This guy didn't change. The W1 went down. W2 didn't change. Okay. And now we apply, using the new weights, we will apply the two test cases. So that's 0 plus 0 times 0.2, 1 times 0. The sum is 0. The output is going to be 0, which is false. The correct output is 0. Life is good, right? Okay, and I'll stop putting weights and corrections there if there's no change. Now our next case is what? It's true and true. So that becomes 0.2 plus 0 is 0.2. Right? And here was the weights. They didn't change. The weights didn't change. This becomes 1 times that plus 1 times that becomes 0.2. greater than or equal to, that becomes 1. The correct output is 1. That's good. No change again. Wow. Are we done? No, we're not done. We're not done because we didn't actually get all the way through a training case, an epoch, all right, without error. So let's just start epoch number 3. All right. So these are all going to be 3, right? Here's our training data. Here's our weights. Oops. Okay. And then we'll just keep going. Okay? So the sum here is going to be 0 again, right? The correct output is 0. The output's going to be 0. The correct output is 0. There's no change, right? Now we're going to have something else, right? So the weights didn't change. If the weights didn't change, we can keep them the same. All right, like that. We're going to keep going. And the main idea here is that at some point we'll be able to get through a whole set of the training data without getting any errors. At that point, the neural network is working. Okay, at least on the training data. All right, and that's your homework. So your homework is going to be to complete the training of this neural network. The spreadsheet I'm going to give you has just the first few lines here, okay? And you will finish it up. Just go through until you get an epoch which does not have any errors, and at that point you'll see what the weights are. All right, so this is really like smaller than even a hello world for neural networks. It is pretty dinky. On the other hand, I think it gives a pretty good intuition as to how this is working. You can see the weights moving around. Here we moved this one down, we ended up moving it up again. Okay, but eventually they converge. Eventually they converge on the right value. So that's kind of the main point. Of course, the fact that this transfer function is so simple is one of the reasons why the calculations of the adjustments and things like that is pretty simple. But that's okay. That's fine. It still has all the right features. So with that, I will sign off for the moment, and you guys can download that spreadsheet and do your homework.